Assalamualaikum, Madam. Saya Amar Razaman. Okay, untuk pembentangan midterm saya pada hari ini, saya akan bentangkan topik bertajuk Continuous Query over Data Stream. Ini adalah table of content apa yang akan ada dalam sepanjang slide saya ini. Yang pertama ialah kita akan kenali apa itu traditional query, apa itu continuous query, perbezaan antara continuous query dan juga traditional query. Seterusnya, kenapa kita interest dalam continuous query ini dan juga real example yang digunakan dalam aplikasi harian. Seterusnya, data stream, apa itu data stream, dan juga continuous query algorithm yang digunakan dan juga benefit serta limitation dia. Apa itu traditional query? Traditional query is a query that are very passive and it is operate over a snapshot database, and it is find the answer, and once it return the answer over the current snapshot and it ends. Di sini maksudnya dia hanya jalankan satu proses. Bila proses itu tamat, dan dia ni akan habis di situ sajalah. Traditional query ni hanyalah untuk kita execute logical dan bukannya untuk kita modify apa-apa current state. Okay, next is what is continuous queries. Continuous query is a query that is issued once over a database and then logically run continuously over the data until the continuous query is terminated. Continuous query let user get the new result from database without having issue the same query repeatedly. And continuous query are best understood the contrast to the traditional query over database that runs once to completion over the current data in database. So continuous query ni dia continually running the query, berbeza dengan traditional query tadi. Next is comparison between traditional queries and continuous queries. Traditional query have passive, short-lived and static data, while continuous query have active, long-running and dynamic data. So, why we interest in this continuous query over the traditional queries? It is interesting to look at continuous query because it is offer interesting way to monitor and interact with a dynamic system. For example, you could monitor the state of the system whenever the system reach interesting state that you might want generate an outlook, or you could detect any suspicious activity on the state. The main point of continuous query is to stay active at all points. For the real example that being used in the application is, first example is network of internet router. In this application, we will monitor health of network and we will able to generate alert if there is any significant drop in performance and also any suspicious activity. Next is stock exchange. Here we can stream of stock tickers and generate report if there is any interest pattern that we have setting. Okay, next is what is a data stream? Data stream is a data that is generated continuously by external sources, which is typically sent in a data record simultaneously and in a small size. Example of data stream is such a log file, web application, e-commerce purchases, information for social network, and financially trading flow, and so on. Okay, actually there is 5 way to we determine if the data is a data stream or not by looking at their specification. First specification for data stream, it must be push. Data stream must come from external sources and it push to you. And also continuous query have no control over this data stream. That means you can only do one scan or one look over this data. Next is arbitrary sequence. Because it is come from external sources, that meaning you cannot control the sequence of the element. This also same by arbitrary rate. And the last specification for data stream is potentially unbounded. Data stream potentially have unbounded data and have no limit. There is several researches about how we can manipulate data stream using continuous query. One of them is a sliding window aggregate. So, what is sliding window aggregate? In sliding window aggregation, the input collection consists of a window over the most recent data item in a stream. Here, a stream is a potentially infinite sequence of data item, and the decision on which data item are the most recent at any point in the given is by a window policy. So what the meaning by this is that we can setting for the specific time frame for each sliding window aggregate of over the data stream sequence. So by doing this, we can split the data stream into multiple sliding window aggregate. Next is why we use sliding window aggregate. Aggregation is a fundamental operation that is very useful for any kind of monitoring application. So they occur naturally frequently for all kind of monitoring application that we have currently. And also often this monitoring application is more important for you to look at the recent data than something that happened months back. Because sliding window display the most recent data, so this is the very useful for any monitoring application. Here is an example of sliding window aggregation usage is first we can create alert if the average traffic volume in the last 5 minutes is 20% greater than the average over the last 1 hour. And secondly, we can find all stock between $20 and $200 that have moved down more than 2% in the last 20 minutes, and there has been a significant buying pressure in the last 2 minutes. And thirdly is we can create alert if more than 40% of a router saw 10% increase in traffic in the last hour. So when we see the example, and we can see there is a time frame for each operation. So here is the example of sliding window aggregate code, but here we only can see it theoretically, and we cannot do any technical because I don't know where to execute this code or how to use this code in any TBMS. So next is limitation of sliding window aggregate. There is several limitation for sliding window aggregate. First of all is a large number of query. When you have a large number of query, it is not feasible for you to independently handle each of them, just because every time you have new input and you need to update answer to each sliding window aggregate. Okay, next is limited memory. So how many memory do you have to handle this sliding window aggregate is limited. This is because every element in sliding need to be stored to be remembered. And also thirdly is distributed input. What happens if the stream is not located in one point, in one location, but it is split across the multiple nodes? So here we need to merge all of this aggregation into one places before we can use it. Okay, what I can conclude here is if we want to manipulate data stream, we cannot use any traditional query, but we can use continuous query. In continuous query itself, there is several method or algorithm that we can use. One of them is a sliding window aggregate. This method, the way we choosing which method to use is by looking at what application that we want to build. For example, monitoring application, we can use algorithm such as sliding window aggregate. Okay, that's all for me. Thank you, madam.